Hello students, in previous lecture we have studied about the features of VBT theory. Then steps involved in VBT theory, these are studied in previous lecture. Today we are going to study about the compound formation, that is coordinate compound formation takes place according to the VBT theory. Then first of all we have to study about the formation of coordinate compound takes place which having coordination number 4 and having tetrahedral geometry according to the VBT theory or using the steps involved in valence bond theory. Then see here the example of tetrahedral coordinate compound is NiCl4 2 minus. See, IUPAC name of this compound is tetrachloronickelate. Nickelate, here ATE suffix is used in the name of metal atom because here that complex ion is anionic in nature. Therefore, nickelate. Whereas here in this complex Ni ion is in 2 plus, that is Ni 2 plus ion is there at center in the complex. Therefore, in parenthesis we have to write 2, that is Roman number 2, and as it is an ion, therefore ion is used in the suffix. Then the IUPAC name of this complex is tetrachloronickelate 2 ion. Then see here in this complex the charge number is -2 and the oxidation state of central metal ion, that is +2. Therefore here first of all we have to write the central metal atom which having atomic number, that is 28, and therefore electronic configuration for nickel is argon 4s2 3d8. But in this complex nickel 2 plus ion is present. Therefore, we have to write the electronic configuration for Ni2 plus. Therefore, electronic configuration for Ni2 plus is argon 18, 3d8 and 2 electrons from 4s. It is loosened by the nickel atom. That means 2 electrons which is present in the nickel atom is lost by nickel atom during formation of Ni2 plus. Therefore, valence electronic configuration of Ni2 plus is 4s0 3d8. Then we have to write the orbital diagram or electronic configuration for this, that is 3d contains 5 suborbitals or subshells and 4s which is empty or vacant orbital. As there is 4s orbital, 4p which having 4px, py, pz, 3 subshells are there. See here 4p orbital is also vacant, that is 4p0. 4s orbital is also vacant, therefore 4s0, and 3d8, that means there are total 8 electrons present in 3d orbital, 5, 6, 7 and 8, and there is 2 unpaired orbitals are there while 3 paired orbitals are there. Then Ni2 plus ion provides vacant orbitals, whether it is s orbital, p orbital or d orbital, to the ligands. But before providing the vacant orbitals to the ligands for formation of coordinate bond with ligands, first of all, these orbitals of central metal ion undergoes hybridization. See here, there are 4 chloro ligands are there. 4 chloro ligands are there, which require 4 vacant orbitals of Ni2 plus. And see here, when chloro ligands approaches towards central metal ion, that is Ni2 plus, then here chloro group is weak filled ligand. Weak filled ligand. Therefore, here that pairing of electrons does not take place. That means there are 2 unpaired orbitals of 3d orbitals of Ni2 plus. The electrons, unpaired electrons in 3d orbital does not get paired because of nature of chloro ligand. Therefore, here 4 chloro ligands requires 4 empty orbitals of Ni2 plus. Therefore, there are 4 empty orbitals are there of 4s orbital and 3 4p orbitals, which first undergoes sp3 hybridization. sp3 hybridization, and therefore that Ni2 plus ion, nickel 2 plus ion undergoes sp3 hybridization, in which that is d orbitals, that is 3d orbitals does not involved in this hybridization. Therefore, electrons in d orbitals remains as it is, and here 4s, 1 4s and 3 4p orbitals undergoes hybridization, and it forms 4 new sp3 hybrid orbitals. Hybrid orbitals of Ni2 plus metal ion. Then these 4 sp3 hybrid orbitals are vacant, and therefore when 4 chloro ligands approaches towards Ni2 plus ion, then it provides 4 new hybrid orbitals to the 4 chloro ligands, and therefore here NiCl4 2 minus complex ion or compound or coordinate compound formation takes place, which having electronic configuration like this, that is 3d8 electrons are there. That means here out of these 3 orbitals are paired and 2 orbitals remains unpaired, and here the 4 chloro ligands donate 4 lone pair of electron which occupies the orbitals, that is sp3 hybrid orbitals of Ni2 plus, and here complex formation takes place because of overlapping of 4 sp3 hybrid orbital of Ni2 plus and 4 paired orbitals of 4 Cl minus or chloro ligands, and therefore the compound formation, coordinate compound formation takes place here, which having 2 unpaired electrons are there. Therefore this compound is paramagnetic in nature. Why it is paramagnetic in nature? As it contains 2 unpaired electrons are there. Therefore, it is paramagnetic in nature. And here hybridization takes place in the central metal ion, that is Ni2 plus is sp3. Therefore, the coordinate compound formed here having tetrahedral geometry. Then the geometry of this complex is like this. Central metal ion, that is Ni2 plus, is at center, which is surrounded by 4 chloro ligands, that is the tetrahedral geometry of NiCl4 2 minus coordinate compound. Similarly, one more example, that is coordinate compound which having coordination number 4, but that compound which having square planar geometry. Square planar geometry. The example of coordinate compound, that is NiCN4 2 minus, in which the central metal ion is in also +2 oxidation state. Therefore, here Ni2 plus ion are surrounded by 4 cyano groups. Then first of all, we have to write the electronic configuration for Ni2 plus, in which 26 electrons are there, that is argon 18, 3d8, 4s0 and 4p0. Similarly, like in the last coordinate compound, that is in Ni2 plus, 8 electrons are present in 3d orbital and 4s orbital and 4p orbitals are vacant. Then here 4 cyano ligands are there, that is 4 Cn minus cyano ligands are there, which forms the coordinate bond with Ni2 plus in this complex, as cyano group is strong filled ligand. Strong filled ligand. Therefore, here pairing of electron, unpaired electrons takes place in 3d orbital. That means here one unpaired electron which is present in d orbital, it get paired with another unpaired electron present in 3d orbital. That means here 3d8 electronic configuration of Ni2 plus ion, but here all 4 orbitals out of 5 orbitals are paired, because here pairing of electron takes place in 3d orbital, and therefore here the hybridization in Ni2 plus ion, that is d sp2 hybridization takes place. d sp2 hybridization takes place, and therefore here Ni2 plus provides 4 vacant orbitals to the cyano ligands, and therefore here the hybrid orbitals, that is, see here 4 orbitals of 3d are totally paired, in which 8 electrons are there, and 1 3d orbital and 1 4s orbital and 2 4p orbitals are involved in hybridization. Therefore, there are 4 new hybrid orbitals are formed of dsp2 hybrid orbitals. 4 new dsp2 hybrid orbitals are formed by Ni2 plus ion, and 1,4p z orbital remains as it is, which does not take part in the hybridization. And when 4Cn minus, that is cyno group, which donates electrons to the Ni2 plus, and therefore the electronic configuration of valence orbitals in the coordinate compound, that is NiCN 4 2 minus, that is here 2 electrons from 4Cn cyno ligands takes place, and here complex formation, that is NiCN4 2 minus complex formation takes place. See here, in the valence orbital of this complex, there are all paired electrons are there in the valence orbital of this complex. Therefore, this complex, that is NiCN4 2 minus complex, is diamagnetic in nature. Diamagnetic in nature. Diamagnetic in nature. While here pairing of electron takes place, therefore spin pairing complex formation takes place. And see here, when spin pairing takes place, then that complex is high spin complex. High spin complex. And see here, hybridization takes place in Ni2 plus of this complex is dsp2. Therefore, here the geometry of this complex is square planar. Geometry of this complex is square planar. Therefore, we have to draw the square planar geometry of this complex, in which the central Ni2 plus ion, which is surrounded by 4Cn minus ligands in square planar geometry. That is the geometry of NiCN4 2 minus. Then we have to study about the formation of coordinate compounds which having coordination number 6, and the coordinate compound which having coordination number 6 having geometry octahedral. All of you studied about that in previous lecture. If the coordination number of central metal ion in coordinate compound or complex is 6, then it is octahedral in nature, or the geometry of that complex or coordinate compound is octahedral. Then we will study few examples of coordinate bond formation having octahedral geometry. Then first of all, see here the compound or coordinate compound which having octahedral geometry. Formation of this compound takes place according to the VBT theory, that is valence bond theory. That is first one example of octahedral complex, that is Cu NH3 6 3 plus, or it may be CO NH3 6 3 plus. See here, similarly we have to determine first the oxidation state of cobalt ion, which is present at the center of the complex. As NH3 is neutral in nature, therefore no charge is present on amine ligand. Therefore here central metal ion of which oxidation state is 3 plus. That means CO3 plus is central metal ion in this complex. Then the cobalt atom, which having atomic number 27, therefore electronic configuration of cobalt is argon 18, 4s 2 and 3d7. Then see here the valence electronic configuration for CO cobalt atom is 4s2 3d7. But here in this complex cobalt 3 plus ion is there. Therefore first of all we have to write the electronic configuration for CO3 plus. See here oxidation state is 3 plus, therefore 2 electrons from 4s and 1 electron from 3d orbital are loosened by the cobalt atom. Therefore there are in CO3 plus 24 electrons are there. Therefore valence electronic configuration for it, that is 4s0 and 3d6. Out of this, see here 4s orbital is vacant. As 4s orbital is there, 4p orbitals are also there, which is empty, and 3d orbital in which 6 electrons are there. Therefore there are, see here in this complex formation 3d 6 electrons are there, in which one 3d orbital is paired orbital while other 4 orbitals are unpaired. But see here in this complex or formation of this complex CONH3 6, which is low spin complex. It is low spin complex. As it is low spin complex, NH3, that is amine ligand, is strong filled ligand. Here the strong filled ligand, and therefore here the complex formation is low spin complex. Low spin complex, and therefore here pairing of electrons takes place in n-1d orbital. That means here there are 6 NH3 ligands are there, which when approaches towards CO3 plus ion, then it forms the low spin complex. Therefore before donating electron by NH3 group to the CO3 plus ion, that here the electrons, unpaired electrons in 3d orbitals get paired. That means pairing of unpaired electron in 3d orbital takes place in CO3 plus ion. Therefore here demotion of electron takes place and pairing of electrons takes place in 3d orbital, and 3d orbital becomes vacant. And see here 4s orbital which is vacant, and 4p orbitals are also vacant, and therefore here 6 orbitals, that is 2 3d orbital and 1 4s orbital and 3 4p orbital involved in the hybridization. Therefore here D2 sp3 hybridization takes place. Here in hybridization 3d orbital, that means n-1d orbital is involved in it, in the hybridization, and here the hybrid orbital, that is 6 new D2 sp3 hybrid orbitals which are formed by CO3 plus ion before formation of coordinate bond, and here therefore 6 NH3, that is amine ligand, donates 6 lone pair of electrons in to the CO3 plus ion, in which 6 D2 sp3 hybrid orbitals of CO3 plus overlaps with paired orbitals of 6 amine ligands, and therefore compound formation or coordinate compound formation takes place here, that is CO NH3 6 3 plus, that complex or compound formation which having electronic configuration, that is 3d6, and the hybrid orbital which is completely filled with electrons, which is donated by NH3 group, that is 6 NH3 group donates electrons to the CO3 plus ion, center metal ion, and formation of complex takes place. That means here, see here, the hybridization takes place in this central metal ion, in this complex is D2sp3. Therefore this complex have octahedral geometry. As here before hybridization pairing of electrons takes place in 3d orbital, and here n-1d orbital is involved in it. Therefore this complex is also known as spin pairing complex, and spin pairing complex, that means which is low spin complex formation takes place. Low spin complex formation takes place. As here n-1d orbital is involved, therefore it is inner orbital complex. Therefore the complex nature of complex is inner orbital complex, and here all orbitals, valence orbitals, are paired. Therefore it is diamagnetic in nature. Diamagnetic in nature. See here the complex CO NH3 6 3 plus, which is low spin complex, because here spin pairing of 3d orbital takes place and coordination number is 6 and hybridization takes place is D2sp3. Therefore here the complex geometry of this complex is octahedral geometry, and as here n minus 1d orbital is involved in the hybridization or complex formation. Therefore, this complex is inner orbital complex. Similarly, we have to studied about the coordinate compound, which having coordination number 6 and having octahedral geometry, but which is having high spin nature. That means the complex formation takes place of octahedral geometry, which having the nature that is high spin complex. That means another example, that is second one example, that is CO F6 3 minus. See here, it is also anionic complex. 3 minus is a charge number in which fluoro ligands are there, which carries -1 charge on it. Therefore, here in this complex, cobalt 3 plus ion is present, and therefore similarly, first of all we have to write the electronic configuration for CO3 plus as cobalt atom, which having atomic number 27, and therefore the 24 electrons are present in CO3 plus ion, because it loses 2 electrons from 4s and 1 electron from 3d orbital. Therefore, electronic configuration, that is valence electronic configuration for CO3 plus ion is 3d6, 4s0 and 4p0, as there is 4s orbital is there as well as 4p orbital is there. Therefore, there should be 4d orbitals are also present, but which is vacant in nature. That means 4d orbitals are there also, which is having 5 sub-orbitals are there. Then see here, electronic configuration, valence electronic configuration for CO3 plus is 3d6, 4s0, 4p0, 4d0. Then as here F, that is F minus, fluoro ligands are there, fluoro ligands are there, as that fluoro ligand is weak filled ligand. Therefore, it forms the high spin complex. High spin complex. And as it is high spin complex, therefore, the pairing of electron does not takes place. That means here electrons remains unpaired in 3d orbital. Therefore, here as there is coordination number of this central metal ion, that is 6, and therefore geometry is octahedral. Therefore, CO3 plus ion should provide 6 orbitals, 6 vacant orbitals to 6 fluoro ligands. See here, there is 1 4s orbital which is vacant, 3 4p orbitals are vacant. Here d orbitals, in which 1 orbital is paired and 4 remaining orbitals are unpaired, and here a pairing of electron does not takes place due to the nature of fluoro ligand. Therefore, here in hybridization, 4s orbital, 3 4p orbital and 2 4d orbital, out of 5 2 4d orbitals are involved. Therefore, in CO3 plus sp3d2 hybridization takes place, and therefore here the hybrid 6 hybrid new orbitals which is formed, that is, see here, 6 new hybrid orbitals are formed, which is sp3d2 hybrid orbitals or hybridized. Here 6 sp3d2 hybrid orbital of CO3 plus takes place, and here the unhybridized orbitals or 4d orbitals remains as it is. See here, the new sp3d2 hybrid orbitals which is provided to the 6 fluoro ligands to forms the coordinate bond for overlapping of these 6 sp3d2 orbitals with paired orbital of 6 fluoro ligands, and therefore complex formation here is COF6 3- in which the orbitals of 3D, that is in which one orbital is paired while 4 orbitals are unpaired, and here 6 hybrid orbitals which get completely filled by donating lone pair of electron by each 6 fluoro group to the central metal ion, and therefore formation of compound takes place. That is formation of coordinate compound which is formed here, which contains 4 unpaired electrons. Therefore it is a paramagnetic in nature. Hybridization is sp3d2 type. Therefore this complex is having octahedral geometry, as here pairing of electron in 3d orbital does not takes place. Therefore it forms the high spin complex or spin free complex. High spin complex, or it is also known as spin free complex. And here nd orbital, not n-1d. That means here instead of 3d orbital, 4d orbital is involved. That means here nd orbital is involved in the hybridization of CO3 plus. Therefore this complex is outer orbital complex. That means here the COF6 3- complex or coordinate compound is spin 3 complex, which is also known as high spin complex, which is also known as outer orbital complex, because here nd orbitals are involved in hybridization of center metal ion, and the coordination number of this complex is 6. Therefore it is octahedral geometry, and orbitals of complex formation in which 3d orbitals are unpaired. Therefore it is paramagnetic in nature. That is about the formation of octahedral coordinate compounds, square planar coordinate compounds, and tetrahedral coordinate compounds takes place according to the VBT theory. One more thing we have to discuss on the limitations of this theory. Limitations of VBT theory. First of all, this theory does not explain the color formation of coordinate compound. Coordinate compounds formation takes place of different color. That means K2Cr2O7, potassium dichromate is orange color. K4FeCN6 is dark green color in nature. Color of the compound or complex does not explain by this theory. That is the first limitation of VBT theory. Second one limitation, that is this theory cannot explain about the nature of ligands. Few of the ligands are strong field ligand, while other few of them are weak field ligand. This theory cannot distinguish between weak field ligand and strong field ligands. As well as one more limitation is there. This theory cannot explain about the formation of high spin complex as well as low spin complex. That is the third one limitation of this theory. And one more limitation of this theory is the structure, that is geometry of complex, which is predicted by the VBT theory. In few cases that cannot be determined by experimentally. That is the limitations of VBT theory. Then in next lecture we will discussing about the stability of the coordinate compounds and factors affecting on the stability of coordinate compound formation, as well as application of the coordinate compound in different fields. That's all. Thank you.